Hello everyone, welcome to this video highlighting one of the features or enhancements to the Cisco Secure Firewall. My name is Christopher Grabowski. I am a technical marketing engineer with Cisco Systems. This is one in the series of videos created to discuss and demonstrate the latest updates within 7.0 release of software. In this video, I would like to show you the new Identity Firewall feature, the dynamic objects. In the good old times, we had a very clear boundary between the corporate assets and the rest of the world. The internal traffic was considered trustworthy, and the goal was to protect it from the external networks. The boundary between trusted and external was clearly defined and protected by a firewall. The firewall policy was fairly static and manageable. As the workforce shifted to remote work and the journey towards the private and public clouds gained momentum, the boundary between trustworthy and external resources diffused. The network and the applications are no longer static, and the shape of your infrastructure changes faster than ever before. The VMs and containers are dynamically spinned up and down to scale the workloads in the real time. As the security threats became much more prevalent and pose greater risk, you need a strict and up-to-date firewall policy more than ever before. Firewall security policy needs to adapt in real time to the ongoing changes in your infrastructure. Cisco Secure Firewall 7.0 introduces dynamic objects, a new type of attributes that can be updated in the real time across your physical and virtual firewall deployments. This feature allows you to map IP addresses to dynamic objects to reflect the state of your network. With dynamic objects, the firewall rules are updated on the fly and enforce the policy accordingly. For example, if a virtual machine is powered down or no longer needed, you can remove its IP address from the dynamic object on the fly without policy deployment. Similarly, if you need to scale up your application or add a new server to the workload, the dynamic object can be updated at the same time. With the dynamic objects, you can continuously keep your firewall policy secure and up to date at any point of time. The dynamic objects are available since 7.0 release. In your policy rules, you can use the dynamic objects as both the source and the destination matching criteria. Most importantly, the objects are updated by the FMC in the real time to the managed firewalls without the need to install the policy. Prior to 7.0, Cisco Secure Firewall has already supported SGTs, user to IP, and other ISE attributes. We wanted to give you more flexibility to keep your policy up to date and easier to manage. For example, you can configure a dynamic object mapping a workload in Azure and use it across all physical and virtual firewalls in your network. As soon as an IP is added or removed from the workload, the change is instantly propagated to all your enforcement points. We updated the GUI with a new type of external objects in the FMC. Once you configure a dynamic object, you can use it in your access control policy. A new set of REST API resources was introduced to allow external applications or scripts to add, delete, or modify the objects. On the monitoring side of things, if the traffic is matched by a dynamic object, you'll find the details in the newly created columns in the event viewer. Let's have a closer look at the dynamic objects. In the example, FMC manages a firewall protecting a workload. A dynamic attribute representing the workload is applied in the access control policy, allowing HTTPS traffic. The dynamic object is mapped with an IP address representing a single server in the workload. The firewall keeps the dynamic object to IP address mapping in the Snort's identity database. Now let's imagine a new server is spinned up in the workload. A custom script or Cisco-provided application, Cisco Secure Dynamic Attributes Connector, can trigger a REST API call to add the new IP address to the workload dynamic object. At the same time, the FMC pushes a dynamic update to the managed firewall, adding the new IP address to the identity database. From that moment on, HTTPS traffic is allowed to both servers in the workload. If you would like to learn more about Cisco Secure Dynamic Attributes Connector, please refer to the corresponding video in our Firepower Threat Defense 7.0 update series. Let's have a look at the topology I'll use in the demonstration. In the lab, FMC manages an FTD firewall that enforces policy between Windows endpoint and a workload server. Through the course of this demonstration, I'll configure an attribute-based policy allowing access to the workload server. First, we'll set up a dynamic object representing the workload. Then, we'll use this object in the access control policy and deploy the change to the firewall. Once the policy is installed, we'll use Postman REST client to add and remove IP addresses from workload A dynamic object. You'll see in the real time how fast FMC updates the object on the managed firewall, permitting or denying the traffic. I am now logged on to the FMC. Let's start with configuring a dynamic object representing our workload. I'll navigate to Objects, Object Management, External Attributes, and Dynamic Object. Here you can see the list of already configured dynamic objects, along with the number of mapped IP addresses. The sample dynamic object, already configured, has 5 mapped IP addresses. You can display those addresses by clicking the download arrow. Let me add a new dynamic object representing our laboratory workload. I'll name it workload A and leave the default type. The new object is now available with 0 mapped IP addresses. Later in this demonstration, we'll use REST API to add an IP address to this object. Now, let's use the newly created object in our access control policy. I'll navigate to Policies, Access Control. The managed firewall we'll use in this presentation has demo access control policy applied. Let's edit the policy. At the moment, the policy is configured with a single rule, blocking and logging all the traffic. We'll create a new rule to allow access to our workload using the newly created dynamic object. I'll set up the name and ensure it is placed at the top of the policy. Let's switch to the Dynamic Attributes tab. In the Available Attributes drop-down menu, you'll notice the dynamic objects are available. We can see the workload A dynamic object we created in the previous step. The object can be used in both source or destination criteria. In our example, we'll configure a policy allowing access to the workload, so we'll add the object only to the destination attributes. Finally, I'll enable logging. Our dynamic attributes-based policy is now ready. In essence, the rules will only allow traffic to servers dynamically mapped to the workload A object. The rest of the traffic will be blocked. Let me save the changes and deploy the policy. The policy is now deployed. At the moment, there are no IP addresses mapped to the dynamic object. Hence, the firewall will block all connections to the workload. In the next steps, we'll use Postman REST client to add and remove IP mappings in real time to show you how fast the policy adapts. But before we go there, let me give you a close-up of the REST API resources available on the FMC and how we'll use them in the demonstration. The main advantage of dynamic objects is that they reflect the current state of your network. The IP mappings are updated on the fly by scripts or external applications. To support real-time changes, we introduced a new set of API resources in 7.0. There are 8 new API calls that allow you to modify the dynamic objects and associated IP mappings. The first two allow you to get a list of already configured dynamic objects or to create a new one. The second group of the API calls operates on individual dynamic objects specified with an ID or a name of the object. You can retrieve the contents of an object with a get method, modify its contents with a put, or remove the object with a delete method. The third set supports get and put methods and allows you to control what IP mappings are associated with individual dynamic objects. To use either of those methods, you need to specify an ID or the name of the object. The last API call is used to manage IP mappings in bulk. With this resource, in a single POST request, you can add or remove multiple IP addresses in one or more dynamic objects at a time. If you'd like to check the full list of available APIs and their details, you can connect to the API Explorer on your FMC with the following link. In the laboratory, I will use Postman to send a series of REST API calls to the FMC in order to add or remove IP addresses from the workload A dynamic object. I'll start with the Generate Token API to authenticate to FMC. In the header of this request, you'll see HTTP Basic Authentication with base64 encoded username and password. In the response, FMC will provide an authentication access token that will be valid for the next 30 minutes. I'll cache and use this access token to authenticate my subsequent calls. I will also record the ID of the FMC's global domain where the dynamic object is created. Next, I'll use the get method to request the details of the workload A object. Note that this time, the request is authorized with the access token that we got from the FMC in the previous step. In the body, we get the details of the workload A object. We'll need to cache the ID value to refer the object in the subsequent call. Finally, having all the details, we can send a POST request to modify the dynamic object mappings. As soon as the request is completed, the dynamic object on the FMC is updated and the change is propagated to the managed firewall. In the body of the request, I use the add method to map 172.16.11.100 IP address to our workload object. As you can see, I use the cached ID to identify the object in the request. Please note that the dynamic object could also be referred here by its name. However, for the purpose of this presentation, I included an additional step to get and cache the ID of the object. The last step is to revoke the access token we've got from the FMC in the first exchange. The token would time out after 30 minutes anyway, but as a good practice, we should revoke the access as soon as we finish working with the API. I will use Revoke Access API resource for that purpose. Now let's go back to the laboratory and test these queries in a live network. Here we are at the Postman console. In my collection, I have 5 requests we'll use in the demonstration. The first one generates and caches the authentication token and the FMC's global domain. The GET request obtains the ID of our workload A dynamic object we created previously in the FMC. The next 2 POST requests add or remove an IP address from the workload A dynamic object. I'll use the last request to revoke the access token once we finish. Let's start with the generate token request. In this initial request, we need to authenticate to FMC with a username and password. In the header section, we can see that Postman translates the credentials to base64 encoded value. The goal of this request is to cache the access token and the FMC's global domain ID. I'll save those values to environment variables as we get the response from the FMC. The variables are set in the Postman test. Let's send the request and observe the output. As you can see, we've got an HTTP successful 204 status code. We have a set of key value pairs in the response header. The ones we are interested in are XOUT access token and the global domain UUID. The values are now cached in the environment variables, and we will refer them in the subsequent requests. Let's now run the second call to get the ID of the workload A dynamic object. In the resource URL, you'll see the variable holding domain UUID and a query string asking FMC for workload A object name. In the header, we will refer to the access token variable. The FMC returns a JSON encoded response with the details of the workload A object. The ID of the object is saved to the environmental variable. The next request will add an IP address to our workload dynamic object. In the URL and the header, we'll use the same variables as previously. The body of the request is in JSON format. We'll instruct FMC to add an IP address 172.16.11.100 to the dynamic object that has the ID referred by the variable. The dynamic object could also be referred by its name here. However, for the purpose of this presentation, I included an additional step to get and cache the ID of the object. Before I send this request, let me open Real-Time Unified Events view on the FMC to track the logs. I'll navigate to Analysis, Unified Events, and turn on Real-Time. I'll start a continuous ping towards the workload server. The ping fails as expected. The workload object is still empty, so the traffic hits the bottom deny any log rule. Let me now send the post request, and we'll observe how quickly the policy picks up the update in the dynamic object. It took roughly 2 seconds. Now we can see the traffic hits the workload rule we created. Let's try to remove the IP address from the object, and the traffic gets blocked again. Let's add it again. As you can see, the IP mapping propagates to the firewall almost instantly without a policy deployment. Let's check the contents of the workload object on the FMC. I'll go to Objects, Object Management, External Attributes, Dynamic Object. We can see there is a single IP mapped to the workload A object. Let's have a closer look. We can see 172.16.11.100 IP address. The final step is to revoke the access token we generated for our API transactions. Let me go back to the Postman console and run the request. HTTP 204 status code confirms the call was successful. And that's it for today. I hope you enjoyed this introduction to the dynamic objects. Once you have a chance to install 7.0 software release, I encourage you to give it a try and play around with the attribute-based policy yourself. Also, check out the other videos from our Firepower Threat Defense 7.0 update series. See you next time!